Travel is a movement of people between distant of geographical locations. Travel can be done by foot, bicycle, bus, train, airplane, or by other means. Google Maps, a widely used tool for navigation, is a location search tool that allows you to geolocate a specific point, calculate routes, and find the nearest place of interest, or see the appearance of a street through a Google Street View. Let's imagine that you want to go to your favorite coffee shop in your nearest location, but you have to choose between two paths. Let's call them Path A and Path B. Both paths lead to the same destination. However, the distance is not the same. Now, Google Maps wouldn't give you the exact distance on how far the destination is, based on the path that you wanted to take, and will suggest you the shortest path between the two. Now, the question is, how does that work? Well, there's a bunch of things that are operating behind the scenes, but one of its foundation is the use of Dijkstra algorithm. Dijkstra algorithm was published in 1959 and was named after its creator, the Dutch computer scientist Edske Dijkstra, and which can be used in a weighted graph. The graph can be directed or undirected. Well, one stipulation in using the algorithm is that the graph needs to have a non-negative weight on every edge. So, what is Dijkstra algorithm? In simple terms, it is an algorithm for finding the shortest paths between the nodes in a weighted graph, which may represent, for example, road networks. This algorithm is not only applicable for transportation, but is also used in social networking applications, telephone networks, robotic path for automated delivery, and many more. And now, let's take a look for another example. Well, as you can see here in this figure, we have a total of 6 nodes. Now, let's imagine that our current location is the node 0 and our target destination is the node 6, and we want to arrive at the marked location in the shortest way as possible. First, we start at node 0 and we must select between the node 1 who has distance of 2 and the node 2 who has a distance of 6. Now, since the node 1 has the lowest distance, we will take that path. And then, we will then proceed to the third node with a distance of 5 since we don't have a choice of path. Upon arriving, there are two paths to choose from, the node 4 and the node 5. And while calculating its distance, the node 4 has the shortest path compared to the node 5. And then, we're going to proceed to the node 6, which have a distance of 2. Now, after all of that, we will going to compute the total distance of each node, which is now, we have 19 as our distance compared when taking the opposite side, which we will have 35 as our distance.
Despite these advantages, there are also shortcomings for using the Dijkstra's algorithm. It can't handle negative weights. Let's take a look at this example. Here in this figure, let's imagine that our current location is node A, and we want to traverse towards the node B. Since node A to node B has a distance of 5 compared to traversing the node B, utilizing the node C with a distance of 6. Dijkstra's algorithm will tell that the shortest path to node B is the direct path to the distant location with a distance of 5. By utilizing the node C, this will be the result. Node A to node C has a distance of 6, and then node C to node B has a distance of negative 3, which, if we add, will result to a distance of 3, which is the shortest path. This is where the Dijkstra's algorithm fails, as it will tell us directly that the shortest path is to direct at the node B rather than using the node C.
Let's take a look at this next example. Given that we are from Panabo City and we wanted to travel to Cabacan, Cotabato City, here in our Google Maps, we can see that the Google Maps is giving us a path that we can take in order to arrive at Cabacan. Also, there's a second path that we can choose, which is this one. Right now, we have two paths that we can take. However, the distance is not the same. Now, the Google Maps can suggest or will give you the exact distance that we can travel from Panabo to Cabacan. Here in our first path, which is Panabo, Davao City, up until Cabacan, is that the distance that it has is 105 miles. Now, this is the fastest route because it would only take us 3 hours and 56 minutes. However, if we are going to take the second path, which is Panabo, then Arakan, Antipas, up until Cabacan, the distance is 111 miles, which will take us up to 4 hours and 10 minutes of travel. So, here we can conclude that the Dijkstra's algorithm is being utilized.
Overall, the use of Dijkstra's algorithm is very important for navigation, as it will suggest the shortest path to take in order to arrive at a specific destination. With the said downside, there is a limitation to its full capabilities, and it's something that must be recognized.